We're going to continue practicing solving quadratics or equations that have that x squared term using perfect squares, kind of using that method. And these are a little bit more of a challenging problem. So here we have the x minus 4 squared equals 25. Again, I'm still going to try to get my perfect square on one side equaling a number on the other. And in this case, I do. So I'm just going to take the square root of each side to undo that square or that power. And I'm going to get x minus 4 on the left side. And the square root of 25 is going to be positive and negative 5. We have to remember to take the positive and negative when we're taking the square root of a number. And now I'm going to go ahead. I still want to get x by itself. So I'm going to add 4 to both sides. And I actually have two cases here. I have x equals the positive 5 plus 4, which equals 9. And I have the negative 5 plus 4, which equals negative 1. So my two answers, which I could either write as x equals negative 1 and x equals 9, I could write it like that. Or I could write it using notation saying these are my solutions. My solutions are negative 1 and 9. Let's go ahead and do a problem where on the left side of our equation we don't have just a perfect square. So in this case I have 3 times x minus 2 squared equaling 36. I can't really take the square root of this because I have that 3 that's being multiplied. So I want to get rid of that 3 that's being multiplied. How do I do that? I just divide both sides. Now I have my perfect square all by itself, which is what I want. So I'm going to take the square root of both sides. I get x minus 2 equals positive and negative square root of 12, which I can go ahead and simplify to be, I know square root of 12 is going to be positive and negative 2 root 3. And so now I don't want x minus 2, I just want x. So I'm going to add 2 to both sides. And again, I'm going to get two possibilities. I'm going to get this positive 2 plus square root of 12, or plus 2 root 3. And I'm going to get this positive 2 minus root 12, or minus 2 root 3. So I can show those like that. I'm going to get 2 plus my root 12. I'm just going to write it as 2 root 3 simplified, which I can't really simplify that at all. These are not like terms, so I cannot combine them in any other way. That just remains as that. I will also get 2 minus 2 root 3. And again, I can't simplify that in any way. So I could write it like this. Or I could write it using this. And sometimes if they're, like if this is the same and the only thing that's different is positive and negative, I can kind of simplify it by just saying 2 plus and minus 2 root 3. And this is showing that I do have two different solutions, 2 plus 2 root 3 and 2 minus 2 root 3. Now this is solving a quadratic, but I have 3 terms. It's definitely not as a perfect square. But if I notice something, I notice that if I were to factor this trinomial, tri meaning 3 terms, it would actually factor into being a perfect square. So, so I'm going to try to do that. I'm going to factor this. So when I factor this, this is going to end up being x plus 1 and x plus 1. Oh, I have just noticed that this is really a perfect square. I could rewrite it as this. Now the reason I'm doing it and doing it this way instead of equaling these to be 0 is because I don't have it equal to 0. So I can't set each of these equal to 0 like I could with other problems. And if I were to subtract 64 from both sides to set this side equal to 0, it would not factor out nicely at all. So I'm going to go ahead. This is a nice simple method to solve this. Now that I have a perfect square equaling a number, I'm going to take the square root of both sides. I get x plus 1 equals to positive and negative 8. X is going to equal, I'm going to subtract 1 from both sides, so negative 1 plus or minus 8. That's going to be negative 1 plus 8, and negative 1 plus 8 is 7. And I'm also going to get negative 1 minus 8. Negative 1 and a negative 8 is negative 9. So my solutions are, I'm going to write them in ascending order, negative 9 and 7. So if I were to plug negative 9 or negative 7 into this equation, it would come out to be a true statement. Let's go ahead and tackle one with fractions. Oh no! Well, the first thing I notice is I have a perfect square equaling a number, even though they're fractions. So again, even though they're fractions, I'm just going to do the same thing that I did before, which is take the square root of both sides. My left side turns out to be x minus 3/2. And then my right side, well, let's see, the square root of 7 over 4 is the same thing as the square root of 7 over the square root of 4. The square root of 7 I can't really simplify at all, but the square root of 4 will reduce to be 2. And because I'm taking the square root, I have to take the positive and negative of them. Okay, now this is looking a little like before. The only difference is I have, some fractions, which are okay. I want to just get x equals, so I'm going to add 3/2 to both sides. And I get x equals this 3/2, and I'm going to be adding and subtracting the square root of 7 over 2. Now I could leave it just like this, like I did in the previous example, but I do notice that these fractions, they both have a common denominator, so I could write this as one fraction, which I am going to do. I could write 3 plus and minus the square root of 7 all over 2. And that is my answer, so x equals that. Or I could put those in those little brackets to say that's my solution as well. So just because you see some fractions, don't get scared. You're still doing the exact same thing. And then if you have to add or subtract, just make sure you have a common denominator.